Hello, time for acid-base neutralization. Um, these are just a special type of double displacement, basically the simple form of it is you're going to have a strong acid plus a strong base, and that's gonna produce a salt, not like a salt, an ionic salt, which is basically um, just a metal, ionic metal, non-metal, solid thing. It's it's you'll see when I do an example, and then water. Um, and if you want to know if what a strong acid and a strong base are, on the back of the solubility rules is the list. And these are the ones that are going to fully break up. They're going to be aqueous. So if you've done the owls already, you'll know, and if you have Miss Mock, she mentioned this in class, that a weak acid or weak base, one of the ones that's not on here, it could be classified as aqueous, but it's not fully going to break up. It's going to break up in the reaction, but it's going to come back together in the end. So you need to treat it as solid and not break it up, or you'll get the owl wrong. But so these acid-base neutralization, this is kind of what's happening. I think it's easier if I just do an example. So hydrochloric acid is neutralized by strontium hydroxide. Okay, so if you see hydro and hydroxide, you're going to know that you have your acid base, and so you're going to be forming a salt and a water. So as we remember from last unit, hydrochloric would just be HCl. And then that base would be strontium OH2. And so since it's just another type of double displacement, what's going to happen is this is going to be your salt. These are going to go together. They're not going to switch places. Those arrows are kind of misleading. But they're going to form together. So that's going to be SrCl2. So that's salt. I'll write it above here too. And then that H and OH is going to make H2O, also water. Because even though we write it like that, that's not, it's really more like this, and that's what you can see. You got that hydrogen from here, OH. So, how you balance these? It might not look obvious, but what you're going to want to do is you want the same number of OHs, H's, and waters. And that's going to balance each other out. So we have two bases, two hydroxides. So we need 2 waters, 2 hydrogens, and that's it. And that's literally it for acids and bases. This is only one type. We'll see later in the year stuff that there's other types of acid base, but this is kind of just like traditional, original. You get the hydrogen from the acid, the OH from the base, and you form the salt and the water. And that's literally all that goes into it. It's that simple. You just need to remember kind of this part up here, and you'll be good if you see an acid and a base. So yeah, if you have any questions, let me know, and that'll be it.